Hello, fellow pwndevils. This is your Vice President, Nathan. I just wanted to inform you guys that the video that's going to be proceeding here, which was from a recording for August 31st, 2020, at our just normal Monday meetings, some of the video wasn't properly transitioned between certain screens. Audio is still recording and still working. However, there were certain shots that weren't captured. So if you do have any questions and you have any comments on any of the content that was provided, please drop a comment below, or feel free to message either I or Zion on our Discord, or contact us via email. Feel free to do either of those, and we'll try to get back to you as soon as we can. Without further ado, enjoy the rest of the video.
All right, I'll start up the meeting, Nathan, and then I'll pass it off to you.
All right, that's fine.
Yeah, everybody seems to be here today. For all the people who are interested in the channel, today we're going to be doing some reverse engineering stuff. We're going to be talking about the compilation process. How C is translated into assembly, how that runs on the CPU. A little bit about linking, but today we're really going to try and give you guys like a more advanced knowledge of assembly and being able to relate structures. Some people ask, why do I need to know that? Why can't I just use decompilation code? It's because assembly is very useful to know, especially when you're not able to decompile things, which kind of happens a lot in the real world. So we're going to be doing that, and we'll be signing you guys up for 466. And yeah, that's it. All right, Nathan, take it away, and we can get into getting everybody signed up for Pwn College.
All right, let me go ahead. I'm going to share my screen real quick. Throw up CC466 here. Ooh. Everyone see, oh, that's the wrong one. Hold on, try this again. I do apologize for the technical difficulty. All right. So if you guys haven't seen it, the website is CSE 466. I'll go ahead and throw this in the pwndevils chat channel. Actually, I'll throw it in the announcements just to make it easier to grab. If you haven't signed up for this yet, it's pretty simple. We're going to go to this first main page, and I'm going to log out real quick. We're going to log in, or register, sorry. Click register. And if you are an ASU student, go ahead and use your ASU ID. You don't have to if you're not a student in the class, but it just, for brevity's sake, I guess, for having ASU students. But you can make whatever username you want. So I'm going to call mine Pascal, and then I'm going to use whatever email I want. So nathan.smith@asu.edu. And then, whatever password you want to put in there. And you should be able to hit submit, and it'll go ahead and set you up for this course. So far, there's only a few challenges. Well, there's 100 challenges of the same category up currently. More will be coming in the week to come. Is anybody confused about that process so far? Is anybody having issues with that? If you are, it's okay. What's up? All right. It's good so far?
Yeah, I'm good.
Okay. So that's the case. If everyone's good to go, then I'm going to go ahead and move over to the next topic. We're going to start talking about compilation process. So everyone's good to go.
Oh, wait. Before we move on, did you tell everybody that they have to add their public?
Oh, shoot. Yes.
Yeah.
Thank you. I apologize. That's thanks. Okay. So we're going to go ahead and add our SSH key. If you don't know how to add SSH key, let me go ahead and I'm going to get onto my Linux machine. And let's switch over. Like multitasking here with OBS and and the Discord streams. Okay, so if you haven't made an SSH key before, we're going to go ahead and use the SSH keygen The whole goal here is we want to so we're going to generate our private key as well as our public key at the same time to basically throw onto CSC 466, a CTF, Pwn College, to be able to get our access to it without having to use a password or anything. And we can name this whatever we want. Default, it's IDRSA. I'm going to call it Pwn College. You can call it whatever you want. And just hit enter. You can give it a passphrase. It's usually more secure too, but I tend to not, at least for stuff like this. And then just hit enter. And it'll tell you, it's going to throw it here in your .ssh folder for your home folder. And then if you can cat .ssh and then I called it Pwn College. So pwncollege.pub, or hold on a second. Where did that create it at?
Your local directory, wherever you ran that.
Oh shoot, sorry. I don't know why I didn't throw it in. Okay. Thank you. So, it made it in your current directory. I'm being dumb about that.
Put it in the .sh.
Yep. So, that's your, this is your private key, or at least that's my private key. We basically I'm going to move these into my .ssh just to make it easier to know where they are and they're not in random spots. And so I'm just doing quick move command, throw it in there. If we want to use this key, we're going to take this and we're going to copy it over to Pwn College.
That's your public key, everybody. Don't copy your private key over.
The big difference is the private key it'll say specifically on it private key when you cat it. So just make sure you read it. Public key will basically look just like this. Let me switch over to the screen. And so right here we're on the settings tab. So the top right, you have your settings, and you can go to the bottom here where it says SSH key on the left side. And it'll be one section, and you can just paste your whole key in there. Once you've got that pasted in there, you can just click update. And you can test this by just going into a challenge. But before I move on to that, is everyone doing good so far as for generating a key? So I see someone asking, how do we do this on Windows? You should be able to just generate it the similar fashion. So if I have, for example, let's see, let me change Windows. I'll show you guys.
I know putty gens pretty easily. I'm not sure about PowerShell though, since SSH was relatively recent.
Yeah, with putty you can do it fairly easily because it's in the GUI. For PowerShell though, it should be just the same as doing it in Linux. You should be able to do SSH keygen, and it'll still run the same way. And so you can name it whatever you would like. So if I want to do Pwn College again, and if this is going to act the same way the other one did, it should put it in my current directory. So then I hit enter, don't want to do passphrase, enter again, and my current directory, it's right here. So then, I'll throw this in my .ssh folder, which is also in the user's home directory if you're using Windows. So yeah, all the commands for SSH should work pretty much the same between the both of them. If you are using Windows, and then Mac, of course, should be pretty interchangeable then to both of those as well. So back on here, like I said, you update it, and everything should be good to go on there. If we want to test this out to make sure we can actually run and connect, we can go to one of the programs at least in the baby suite here. I'll give you guys a free one, and that way we can all just chug along real quick and at least connect to it. We're gonna suid or set the SUID bit or UID bit for bin cat, and we're gonna click run challenge. And what this is going to do, it's going to start up a Docker container in the background. It's going to create a copy of the cat binary, set that UID bit, which then it's going to allow us to basically execute cat as root, or as a given user, which in this case is going to be root.
I have a question.
Yeah, what's up?
Sorry, can you explain that part again? Why are we putting bin cat in in the box?
Yeah, so we can put any command in here that's a binary to Linux. The main purpose of this challenge is to give you basically 100 tries to then grab any application that's on a Linux system that's an executable binary. So it's in a executable and linkable format, or an ELF format, which is native to Linux. And so, for example, cat is one of those. You normally use this to open up files. And it's going to make it have special permissions, such as what's called a UID bit, and it's going to set that on the for the person that owns the file. So in this case, the person that's going to be owning it is the root user. And I'll show you in a second too how that's going to work, because normally, if say you didn't own a specific file that was owned by an administrator, you wouldn't normally be able to read that. So the whole goal here is to show that with specific applications, if you set them with these special permissions by accident, you can usually open up a file that you're not supposed to be able to open. And in this case, it's cat, which normally you wouldn't want to set something that just directly like you can open up any file with that right off the bat without having to do anything special, which we'll see. We're setting as that because it's a pretty easy one that we can just go ahead with most ease, just open up a file and just connect to it right now. Because that's mainly what we're trying to go for right now, is just to test everyone's connectivity to the challenge server. Is that all right? Did I answer your question?
Yes, thank you.
Perfect. Okay. So I'm gonna
just to clarify on that. We aren't going to go super big into that whole explanation of the SUID thing, because this is a module out of Pwn College.
Yes.
So we're just going to give you guys the link for the lecture or for the video that kind of explains what this is, because we're going to be using that in like parallel to what we're doing with these meetings. So hopefully, how it will work is, you go home, or I mean, we're all always home, but at home when you're not in the meeting, you open up the link to Pwn College, you watch the video, see how it is, and then you try the challenges, and then you come over here to Pwndevils, and then we kind of reinforce those challenges, and we're kind of like the direct help for these challenges, because you can't all talk to Jan, the professor. There's too many students. There's hundreds of students. So Pwndevils is like the exclusive place where we'll actually solve these challenges with you, or sometimes for you, but not for credit. Yeah, so the whole point of this is just we'll give you the video to watch later, and then you can understand this more.
Yeah.
Quick question for those of us that are in 466 right now. Should we try to, because I know I don't want to necessarily have you guys do the class for us. Should we try to get these challenges done for credit on our own and then come back and see what you guys do, or how should we go about doing that?
So for the people in 466, the objective for you guys is, what would be like ideal is you try to do these challenges before you get to Pwndevils, and once you get to Pwndevils, you come on the challenges you're stuck on, which for you guys it should be the harder challenges. In addition, you guys will be able to help people who are stuck on the easier challenges, which will hopefully benefit you guys. But ideally, you would do the challenges beforehand, and then we can just help you with the hardest stuff. So, for instance, when you get to the ROP section, you'll probably need help on the last two challenges.
Awesome. Sounds good. Thanks.
All right. Awesome. Thank you for that. So then I'm going to go ahead and copy this real quick, this SSH command. One thing we'll have to change on it, which kind of specifies down here. We want to make sure we authenticate with our private key. So we're going to use the attack I option, which just allows you to specify what identity or what key you want to use to connect. So then when we come back onto our Linux instance, one moment, then we'll go ahead and paste that command in there. But we'll actually want to make sure we're using our identity. So I'm going to go ahead and use Pwn College identity, and this is going to be your private key you're going to use, not the public key, because you want to be able to use your private key to authenticate and match your public key on the other side effectively. So hit enter, and it should just right away let us log in, no password needed. If you run into issues with this where it's like, oh, you have bad permissions, something's went wrong with that, it's probably just because maybe you copied it wrong, and you just gotta set it to 600 for using the chmod binary, but if you just use SSH keygen, you shouldn't have that issue. But if you do, just let me know, and I can help you with that. But, yeah.
I have a quick question.
Yeah,
so this video would be located on the announcements, or where would this video be located? No.
We'll put it up in announcements, or we'll let you know where it is. Definitely, like when we post it, it'll be in a very visible spot. If it's on like our website or our YouTube channel or something, we'll post it inside the chat like we've been.
All right, cool, sweet, thank you.
Yeah, of course. All right, so now that that's good, we've connected, so we know that everything's set up. Does anyone have any issues trying to connect and using SSH to use their key to connect to the challenge server?
I have a question. So you said this was setting up a Docker container. Can you just give like a quick synopsis of like what is a Docker container?
I got you for this one.
Okay.
Or because this Docker container is not normal to how like how normal Docker containers work. In this instance, you guys can consider it as a miniature VM. They're running a mini VM on their own system for you guys, so that you have like I'd say like I want to say containerized, but that's like, using the definition, and it's using the word in its own definition. You guys have your own space where you're allowed to mess around on this virtual machine, and your virtual machine won't affect the other students, is the main point. So every time you connect, a new Docker container is created, which is a little, virtual machine, so you don't interact with other students. Other students can't destroy your shit either. You're not even a user on their system.
Definitely really is nice when you start making like scripts and stuff and other people can't see your stuff or destroy your stuff. Did I answer your question, Prison Mike?
Yeah, thank you.
Cool. All right, and does anybody else have any other questions or anything before we move on? Zion, I didn't skip out on anything at all, did I?
Nah, I think you got it.
All right. Cool. All right, I'm gonna go ahead then and move on to what we're gonna move on to. Let me X out of this real quick. All right. So, so we took a poll and we noticed that a decent amount of you guys were fairly familiar with how C works. Generally kind of good understanding of programming. If you use this, you make high-level code, you make some sort of program. I'm just going to pick one out of here, like loop.c. That seems like a fairly simple application, but what really happens when you try to make that executable? Like, if I want to take this high-level code and I want to make it into the ones and zeros that my computer can execute, what happens in between that? And some of you, kind of have this idea like, well, there's assembly, that happens somewhere in the middle. Maybe not sure where, but it happens in there. But you never see it because you don't need to. GCC does it all for you, and that's fine. Though when you're reversing, you don't get the nice C code. Some compile or decompilers, like we mentioned before, may give that to you. But in a lot of cases, if you're given this esoteric language or you're giving something that is purposefully mangled in such a way that a decompiler is going to give you some wacky C code that won't be representative of what the program actually is doing, you're going to need to understand, what is the assembly actually doing? How can I understand certain structures within it and be able to basically follow the program without needing the C code? That's kind of the importance of a reason why we're saying you should understand assembly. But we'll walk through right now what happens from the C code down to at least the assembly part. We're not going to go into linking and stuff, but we'll go and say, hey, we have this C code right here. What does that look like when we start assembling it? So firstly, I want to first go into what is the standard format that you have for Linux. We're all familiar with, .exe, which, if you're not familiar with what maybe the specific format's called, it is called a PE format, or a portable executable format, and that's specific to Windows. Mac has Mach, and Linux has ELF. And all of these are going to be laid out in different formats. We're going to be focusing specifically on the ELF format today since we're working with Linux. But if we're wanting to do a quick object dump, which is going to go ahead and take the program that's currently compiled, and it's going to just dump all of it out. It'll be very different each. So I'm going to do quick. So RLBJ dump. So I'm going to do the tac D, which the big D is for disassemble. And then I'm going to tell it to use what's called Intel syntax. There are 2 different syntax, and Intel is the right one. But there's also AT&T. A lot of people, though, tend to prefer Intel just from starting out as well. I'm going to do the Linux binary first. And we're going to see at least for the head part, a lot of this assembly seems pretty, you're maybe not familiar with it, and that's fine. But if we compare this to something like .exe, this is not going to be called that. I'm just going to stop that there. This assembly looks fairly similar too. Like, they're not very different. This is what I'm trying to at least prove with this is that the assembly is going to be architecture specific. The assembly that you're going to see here is going to be based on x86. This is because I'm working with an Intel processor. There's different formats, of course, which your assemblers will take care of to say this is how we get from, C or Rust down to this assembly format. And each assembly grouping is going to have a different layout depending if it needs to be Windows, Linux, or Mac. But the instructions are pretty much the same. You're not going to see much difference. And, once we start looking at some of these ELF binaries and later on in your reversing career, you'll notice that, the assembly is the same, but the format is going to be slightly different. And that's fine to do. So start with what I was saying before. I'm going to start with like a simple, let's do strings. So strings right here, this is going to be something that just says Yahtzee, and that's all it does. It doesn't actually do anything fancy, no loops, no nothing. We're just putting a word into the assembly called Yahtzee. To basically get this into assembly, I'm going to go ahead and use GCC, and we're going to GCC tech S, and we're going to specify we want it to use Intel syntax assembly. And let's say strings, let's see. And we'll see our strings file, strings.s. .s is going to be the extension that's normally used for assembly. Go ahead and cat that out. Or .s. So, yeah, it is a little different. It's not as big as the other ones, just because the other files we just looked at were linked. So they had every single library that you'll see in Linux, or at least for that specific C code called. So this is like your printfs. This is any of the calls that you do that are functions within the C language that aren't ones you make. So it really expands upon how that binary, or how big that program is. For this, we're not doing much. So, and we also don't have it linked. So it's going to be fairly small for now, which makes it easier for us to look at. We see here we have a section, that's our string section here, that's going to define Yahtzee, which is here. We can basically just see kind of how this is, it's not doing much or if anything. We go ahead and we have this section right here that's going to be what's our kind of our declaration. It's the entry to the program, so it's an entry to the main program. And we have the ending part, which looks more like it's kind of like cleaning up. So cleans up the program and we exit. This middle part here, we're just setting up basically, we have a variable right here called word. We're going ahead and referencing a section of LCO, which is this section right here. And it's referencing it using the instruction pointer. And at this point, it's going to be referencing what this dot string is currently. So this is like a very just simple program for what this is, back and forth to here. Let's see. So if I'm not making sense too, please ask me questions, because it can be a little confusing at first, and I might be explaining it a little weird.
I'll also I'll post these right now so you guys can all get the C code and the assembly, and then kind of follow along with object dump and stuff like that. So you have all these useful commands and object dump and the C and the assembly, so you can follow along what's kind of going on.
I actually do have these posted as well on the.
Oh, sweet.
Yeah, it's should be in the announcements chat. I don't know if everyone's able to see that, but it should be there, and then you should be able to download those files and follow along. They should be separated. I don't have them all in a zip at all, but yeah. So I'm gonna go ahead then, and I'm gonna open up another one real quick. I'm gonna open up this stack one, stackdex.c, and here we're using an integer value. This should be a little easier to look at and see and follow along. Because with this, we're just assigning an integer to 15. Integer should be 4 bytes for this, but it might be, depending on how the assembly looks, we're doing it for a specific architecture. It might show up differently, but we'll look at the assembly and see what that looks like. So we'll go ahead and run our GCC command to go ahead and stack deck. Now, one thing I also do want to compare to real quick is what does this look like compared to, if we had just the regular stack deck. We already compiled it and everything. So we have object dump, deck D, I'm going to do Intel. So we're going to disassemble this stack deck binary, which has already been compiled fully. So it's going to have everything kind of going on with it. It's going to have all the linking. It's going to have everything inside. So it's going to look a lot bigger. So you see already, this is many more lines than this, but we can still find where this code is. All your executable code is going to be inside this .text section, and we all are familiar with C, so every program, or every C program at least, should have a main. This is this section right here. And we can see some similarities, so we see push RBP, we see push RBP RSP right here. We see dword pointer, -4, so it takes the base pointer and it subtracts 4, which we see this right here. It's written a little differently, but that's more of just the translation between just having straight shellcode, or not shellcode, but assembly, and then having a compiled binary, which then we're trying to disassemble after the fact. And then, yeah, so we can see basically the only things we're missing though are these CFIs that are usually taken care of upon once we finish linking and once we finish fully compiling the program. But as far as the differences between the two here, our int value set to 15. Well, we can see we have our initial beginning of our function. We are not doing anything yet, but then right here, we're moving 15 into RBP minus 0x4. So what we thought was an integer, which we saw, so we don't need to really think much about that. But we know that it's 4 bytes. So we can see there that it subtracted 4 bytes from wherever it was at to make room to basically store this value 15. We don't see this value like name. We don't see that inside here really. We just see main and a bunch of assembly. There's no variables. There's no nothing. Even here, like the section that we saw before, which was up here, and to actually look at what where's our string value at. This is not a string. These are different types, so they're going to be stored a little differently. We don't even need to store a continuous string. These are just a singular value. And so we can just kind of throw this into that section. This is going to be some part of the memory. And then it's going to make sure that, let's see, we don't do anything else with that. So there's nothing else special with it. It takes that value, it throws it into a register, and we don't do anything else with it. It just returns right after that. So it's super simple. Like there's a lot of, if you're doing this object dump stuff, you'll see there's a lot of these other sections. You don't necessarily need to pay attention to those, because you'll see a lot of these that are __ libc. Those ones tend to be just libraries. They tend to not be anything that's specific to the functionality of this program, but you'll usually be paying attention to key things that are not the same, or if you do want to look into those libc functions, you can, but for the purposes of like these problems and these challenges we're going to be doing today, really should just be paying attention to main. If we have another function, it's called vuln, or something that's it will tell you that this function is something you need to look at. It'll be very obvious. And does anyone have any other questions so far? I'm going to start pulling up the next, which we're going to look at how if statements look in assembly. Okay. So for those of you who are not too familiar with assembly, you may not have heard of branches. If you are, then you know what branches are. If statements can be represented in what's called branches in assembly. You don't see in any of these here. Of course, we didn't have any if statements, but if I was to run this same command on, say, the branch version of the program, I'm going to move over to main real quick. There we go. We don't see anything that's written out that says if or else. What we do see is we start seeing these JNEs. If some of you who have done MIPS probably see BR or BQ, and those are just different, they're called branches. And this means that based on some condition, or just happens automatically, and I'll explain both those cases in a second, you end up moving to a different part of the code. Or a different part of, in this case, if we're looking at the assembly, it's going to move to a different part of the assembly. And in this case, it's the main function plus 0x46. The part where we start moving to different places just without making a decision, those are just normal jumps. If statements, of course, we don't do that with. This is like if you're doing any type of function call or you're trying to move somewhere else. But a branch that's a conditional branch, so this means there's something that you have to do or something that happens that causes the decision to, make a certain move versus not making another one. In this case, if we look at the if statement here, we're comparing a value which it needs to equal 1337, and we're going to go ahead and make sure that it does. And if it does, then we'll go ahead and print out you were late. And if it doesn't, we're going to print out you were not late. And then we're just going to return the value. And, this is going to be some decision here. So here, we'll look for the first jump value, which is right here. And what we're comparing is this 0x539 to some value here at 0x4, or RBP minus 0x4. And if we remember from, our knowledge of data types and what we just discussed a little bit ago, an integer is 4 bytes. So there's probably an integer there, and we can, double check this. Of course, if we're doing reversing, we won't be able to, but we're learning right now. So we can double check this and know that, yeah, that's probably that value right there, because it had saved it on the stack, or at least in one of the registers. In this case, RBP, so it's going to be on the stack, and it's going to say this 4 bytes right here is specifically for this variable. And then later, the next one, it's going to go ahead and compare it to 539. And if we don't know what 539 is, well, we can open up, say, IPython, because I'm definitely not good at interpreting hexadecimal values that are 3 digits long, and that's 1337. I know that came as a surprise to some people. It came as a surprise to me. But there's this value gets compared to, and then we jump if it's not equal. And we can see this right here. So if we say if the value is equal to 1337, we're just going to go ahead and print it out. But if it's not, so if our case is the value does not equal 1337, we're going to move to this other section. And right here, JNE, well, we can definitely look that up real quick, and we can say, well, JNE doesn't equal, or it's not equal, so jump if not equal to 1337. And I will bring up, do you have that, Zion, do you have that assembly table? that you used last year? I forgot what it was.
Um,
The like really nice one.
the syscall table.
Yeah. Oh no, was it the syscall table? No, I thought there was one that had like a lot of common assembly opcodes, or it had all the opcodes listed out basically.
Give me a second. I'll see if I have it.
Okay. So yeah, I'll pull that up in a second. But there's a myriad of different references online too that we could go to, and we can find what does this specific opcode mean for x86, which is the instruction set we're working with. We know that if it is not equal, it's going to go ahead and jump to main, which if we look at what the base address of main is right here, which is hex 68A. So all of these values that you see on the sides and on the top are in hex. And so if we go, I'm going to make sure the output is in hex, so this is a little easier to read. But we'll say, we'll add 0x68A, make sure everyone can see that. And we'll add 6D0 to it, because that's where we're going to jump to if it's not equal. So go ahead and 0x. And
I posted a little reference inside the pwndevils channel for anybody who wants to look at a reference of what the instruction does.
Cool, thank you. Or sorry, not to 6D0. Grab the wrong one. It's plus 0x46. And we'll see that goes to 6D0. So it shows the resolution right here that it goes to 6D0. But where that's located is 0x46 more than the base address of main. And then that's going to go right here, which we'll see that it'll, if we expand the sum, actually, let's go ahead and scroll this up. So jumps to here, and right here we have another print. And what this is loading into it, we can assume is some string value. We don't know what that string value is. I mean, we know what this is here, but we don't know what that string value is currently. Of course, we can try to go hunt down for it. If we assume that we don't know what it is, though, we can always say that where this value is going to be located at in memory, if we were looking at this, say, dynamically, would be at RIP, so the current instruction pointer. It's going to be B0, or sorry, up here. RIP plus 0xAA. So that's going to be where it's going to load into, and then we're going to go ahead and set up for printing. So if we're looking at the different opcodes for like printing out something, we have to set up the registers in a specific manner to allow us to print out. And let's see, I actually do want to show off the syscall table on this part. Do the Chromium one. That one was pretty cool. So let me change my windows real quick.
Oh, if you're talking about the syscall table for x64, you want to use the R Chapman one.
I was going to use the Google one.
The Google one is for only 32-bit.
No, they have a 64-bit one.
What, really?
Yeah. Here, I'll post it inside the pwndevils chat. I believe they have 32 and 64 actually on this. Could be wrong. I don't know where. 32 bits. Nope. That's. So they have ARM 64 and then they have x86.
No, they
64.
got they got 64. Nice.
Yeah.
No, I didn't know that. Wow.
Yeah. So what
I have a question.
Yeah. Go ahead.
Sorry for interrupting. So when it says jump not equal 6D0 and then between two angle brackets main plus 0x46, is that part of the command or is just 6D0 the end of the command?
So what's really nice about like object dump is a lot of times when it's looking at some of these some of the assembly, it'll see something like this where we're taking the base address here and we're saying, if this value is not equal or something happened in this comparison and they weren't equal to each other, we're going to go ahead and jump to main plus 0x46. It'll just go ahead and make that resolution for you right there. So this is just referencing an address is what this is doing. So if you have like the specific point, so we know because we're within this section of main, we know where main is, and we just add 0x46 to it, well, we know that's going to be going to 60. And it's usually easier to reference the current function we're in since we know where that base is than maybe if it's to access or base it off of relative to where we are inside the program, though that can be done as well. But in this case, it chose not to.
All right, thank you.
Yeah. Any other questions or anything before I move on? Feel free to ask questions because, like I said, I may not be explaining this the way you might be liking it to. Okay. All right. So, yeah, let me actually switch my screens real quick. All right, so we have this table right here, which this is called a syscall table. What this lays out is all the different syscalls inside of Linux, or in this case, this is compiled from Linux 4.14 for, I believe that's the kernel version. So in this case, for the program that we were looking at, we saw that it said printf, which we all know is a command for the C library to use to basically we're going to print out something, and it's not just write or open or read or anything like that. But what we'll notice is that there are these registers right here that are up top that look very similar to kind of how what we saw in some of the assembly, which I can go back to and we'll cross-reference this too. But for example, read here. It has RAX, or if you're using 32-bit, is EAX. It's going to make those 0. If it's writing, it's going to make it 1. And then we're going to set our file descriptor. So this is going to be some value that's referencing, if you're talking about 0, 1, or 2. So this is going to be if you're wanting to read or write to standard in, standard out, or standard error. Usually if you go higher than that, it's referencing some sort of file that's not one of those 3. So this could be, a flag file. This could be an output to somewhere else, just on the system. Because Linux is all based in files. So there's no void that it just kind of goes off into. If that void is a void, it's a file that's a void. So when it says file descriptor, you're basically telling it, hey, this number is going to represent this one file, and I want you to go to that one. And then, of course, it's going to be our characters that we're going to write or read from, and then the amount we're going to write or read to. So if I wanted to write to a file, 5 characters, and it was going to be hello, then I would write that to a file and say I'm going to write 5, and then I'm going to make that maybe file descriptor 3. And of course, when you compile a program, you don't have to do a lot of this. But we'll see where that similarity comes in if we do something like, let's change my window, like here, where we have, come back, so we jumped to 60, 0, and we move 0 into EAX, and we called print. 0 is read, so it was reading from some point, and then it went ahead and ran the print function. We're not calling the straight up the syscall right away. We're just setting it up to basically say we're going to set this to 0 and send off the command, and I want you to print out the value that's going to be stuck inside RDI, which RDI is going to be the argument for the descriptor of what we're going to have it basically read out. So that's at least for this small section here. But the main part to get out of this is branches. So the if statements are broken into those branches. They move you around the program, and they're not just if statements, and they're not always consecutive one after another. Like this else statement could be very far after the initial check, but the thing is it'll always tell you, at least in the disassembly, and even if you compile the source code for it to try to get let's see, so even if you look at the small amount of source code, it should look just the same, and you'll see that kind of, yeah, it has those similarities, but here we can actually see where the strings are in the file. So we see that the first string is referencing LCO0, and then the second one's referencing LC1. So it's at the beginning of those. So when we're making the comparison here, we'll say, all right, well, we're going to compare RBP minus 4. We're going to compare that to LEET. And if it's not equal, go to 2. And if it is equal, this is going to be in the case where it does equal LEET. We're just going to keep chugging along. So we're going to execute these next 3 commands. And then this is the unconditional jump I was talking about, which means it doesn't matter. You could be comparing to something or doing anything in the world, and it'll just say, all right, I'm going to go over here. And it just jumps. It just goes to that spot. So in this case, we're jumping to L3. Over here, if we make that comparison, and then we had our next 3 instructions, which are very similar to what this one's set up, and then we had our jump. We jumped to 6E1, which is main plus 057 or 0x57, and we just jumped to 6E1. There's no comparison. It just goes there no matter what. And then we end up and leave and end the program, which we see the same thing going on here. What's nice about at least this one is you can kind of see where those strings are coming from. So when it's going to actually print these out, so we set up, we say grab whatever RAX is, and at least at this point, it should be something from keyword. So it's going to be a value of minus 32 RBP that's being pulled from, going to be this top section here. And it's going to be pushed into RAX. And then we're going to increase RAX and then throw in another value into it. That's a pointer to a value. And then call this value right here, which is going to be our actually pulling in of the user's information from the argv value, and then converting it to an integer. And then we'll do our comparisons afterwards. So all the strings and stuff that are loaded in as variables here and are put in, maybe not as a variable, but there should be in the program, will get pulled in earlier on in the program as well. And so we'll see that. But then later on, if we do want to print that out at all, we can just reference them pretty much based on either, in this case, the labels, or in the case of the actual assembly, they're referenced to some point.
Hey, Nathan.
Hey, what?
Quick question. What was the command you used to get the left side of the terminal?
Yeah, so I use this command right here. Can you see that all right?
Yeah. Okay, so gotcha. Would you just do it with the dash s flag? Cool, thanks.
Yep, that just basically you're telling it to go and try to compile into assembly code instead of actually going through with the rest of the processing of the program and linking and making it binary and everything. So it's just going straight from your C code to assembly.
The one thing I'll note about that is don't consider that command on the left side as what you can normally do ever. Like you said, it's just for this specific example. What I would recommend if you want to look at this in a more structured way is on the left side of your terminal, bring up the C code, and on the right side of the terminal, bring up the object dump. Then you can directly see how your C code will translate into assembly. Because the nice thing about the one that he showed a second ago was that the C code gets converted into just the main section. Only the main is converted into assembly. But as you can see on the right side, there's all this other shit going on, and they even have stuff like calls to ASCII to integer, to printf, and a bit more inside the main function than was a little bit before.
Yeah, you don't see half of this stuff.
Yeah.
Yeah. Or sorry, go ahead.
No, I just said gotcha.
What were you gonna say, Zon?
Yeah, I was just gonna say that's probably the most efficient way is to have the C on the left side and then have the assembly of just main on the right side. And I think Nathan showed you how you can pipe object dump into less, and then you can just search for the main start and just check it out.
Yeah, I'm gonna do that again real quick just in case you guys didn't catch the actual using less to get the output, because it can be a lot. So you're just gonna do the normal object dump, so you disassemble, tell it want Intel syntax, and then the program you're trying to do. We're gonna use this pipe, and then we're gonna pipe it to less. And less kind of has It feels like, I mean, I guess of like Vim to me. So you can use slash in this, and then whatever the word you want to search for. So you hit slash or /, and then so I want to search for bracket main, and a few of these references might come up, like that one did. That's not actually main. That's just a reference to it. But then this one, which it has its own base address and everything, and then it has a colon, and then all of the disassembly within it, that's going to be the actual main. I just quit out of it. Yeah, and like like Vim, you can also press Q and exit, or not Vim, but yeah, unless you hit Q and it exits it right away. So don't do that, and you'll have to go search for it again. But it's no big deal.
Okay, nice. If you want, we can move into the challenges now. Unless there's some more files to go over.
There are, at least I think this is good enough for now, honestly. The only other one I would say real quick, and I'm sorry if I'm kind of going a little slow with it, is with like loop, if you wanted to.
Oh yeah, definitely for sure. Take a look at loop so you guys have an understanding of how loops get converted into assembly. But I think you guys should be able to use those examples that you guys can all download now to solve these next challenges. And I set up a little fun thing I posted in the pwndevils chat. If you go to that URL, make an account, all the challenges are hosted there, and we can, be on the scoreboard, look cool.
Thank you. I was trying to do that before, and I didn't have enough time.
Yeah.
All right.
Come on, Nathan. You didn't even set up a custom HTML homepage for that.
Dude, I just like, here's a GitHub page. Have fun. All right. Thank you. So yeah, real quick, we'll go over this. I'm going to do object dump again, and which one am I doing? Loop.
Oh, one more thing. Just a heads up for people looking at the challenges now. So reverse 1 through 4. Don't just submit the flag that's in the description, because all the flags are in the description for those first 4. That's just because I didn't want to actually embed a flag into the challenges. So just only submit the flag once you actually got the challenge. Like, just honor system for the first 4. Yeah.
Then the last few.
The last one is a real reversing challenge that I made.
All right. So this one, we have a for loop here. And one thing I do want to pick out is this is actually kind of a good example of maybe a way that a decompiler could be misinterpreting how a loop might look. If any of you have used Ghidra, you've noticed that maybe the decompilation in the C is not a for loop. It's a while loop plus an incrementer. And, effectively it's the same, it does the same thing, but it's just an example I like to say, like, it's going to be interpreted differently depending on how you do, and what program you're using, what you're using to pull it apart. So which is nice because assembly pretty much always the same, especially like if you use object dump or, if you use some other disassembler depending on the format. So if it's like for PE binaries, like for Windows, they'll follow a similar format. And so, you're not going to have any of these weird idiosyncrasies. So that's just one thing I wanted to bring up with that. But we're going to go to our main here. And this one's actually really nice. It's very small. And we can see where this incrementer kind of comes into. So first, we set a value, but we never actually assign it yet, which is fine. So this is where we moved 0 bytes into something -4, so another integer. And then we jump to 60f. 60f is this value right here. And just walking along, what's going on in the for loop, we initialize some I value, which we set to 0. And then I less than 15, so we're comparing with JLE, so J less than or equal to, and in this case it's going to compare that this value is less than 15, but since we're not actually saying less than 15, we're saying less than or equal to, we can't do that with this. It won't work. So we have to say less than or equal to 14, which is what 0xe is. So effectively doing the same thing, but we're just doing it a little bit more to align to what instructions are inside x86. The compiler chose this instruction for this instance. It was the way it intended it. So then it compares that. It realizes, wow, this is This is not it. This is still 0. It's less than 15. It's not greater than. So let's go ahead and jump back. So it goes ahead and moves to 0xd, which this is main plus 0xd, which is 607, which is this part right here. And we're just going to go ahead and take whatever value, which is this value that we had instantiated before, some point, and added 1 to it. So we just add 1. And then we go ahead and we see this value, which is RBP minus 0x4, which is the initial incrementer value. We add another 1 to it. And then we compare it again. Because remember, the plus plus afterwards means that we do it, after we're doing whatever we're doing. If it's done before, we'll usually see whatever comparison or any of the value, like it'll happen first. The incrementing will happen before any other operation on that value would. Then we just go through and we say, all right, lesson still, we'll just keep doing this. And it just keeps going in this loop until eventually we get to this point where we compare. I, or RBP minus 0x4, our incrementer here, is equal to 14, or 0xe. So this jump less than or equal to will go ahead and not work. It'll fail out, and it'll just keep going. Or it won't be taken. It'll just go ahead and just keep chugging along. So then we start cleaning up the program, and we leave, and the program is done. So that's kind of while loops will have a similar fashion. The difference with while loops is you usually won't have this incrementer, and this comparison might be different. Like you may have this jump less than or equal to, or other types of jump not equal, jump not 0 or something. Might be above maybe where the loop starts rather than being down here. But that's just all dependent on the compiler. So you'll see maybe them swapped around, but just realize if you have something that you're just constantly, you get to a certain point and you pop back up, and then you go down and you pop back up and you just have that weird motion. It's a loop, but whether it's a for loop or a while loop really doesn't matter too much. Just what's going on with the data in between. Like, what is it doing? What are we incrementing? And I say it doesn't matter too much with kind of grain of salt, because it definitely could matter depending on the case. But if you're just looking at for structure wise, they're pretty much the same. So the differences between the two should be minute. But does that make sense to everybody? Is that going pretty well? Cool.
Makes sense.
Cool. Thank you. And
wait, what? Sorry. One other thing for people doing the challenges right now: do not use a decompiler. Don't use Ghidra. Don't use Binary Ninja. Just use Object Dump. The point of these challenges is that they should be like medium difficulty, just with assembly. So you just use Object Dump, so you're just staring at assembly. If you have a decompiler, it'll be way too easy. So
He didn't mention IDA Pro. Let's go.
Yeah. All right, that's true. If you have IDA Pro, I guess it's you had 5,000.
Hey, if you have IDA Pro, you have to pass them around for everybody else.
But yeah, only use Object Dump, guys.
if you use a decompiler, we know your Discord username. My dad owns Discord, so.
Yeah, that's true.
Oh, fuck.
My dad owns Discord.
Oh no,
right.
it's Bill Gates.
But no, so seriously though, does anybody have any questions on this? Like, I kind of just, I don't know, I went through it at a weird pace, I feel. So if anybody does genuinely have any questions or they don't understand, it's fine. This is not a easy concept to just kind of pick up all of a sudden if you haven't before. So
I have a question.
Yeah, of course. What's up?
For Object Dump, do you have to compile the C file?
Yeah, so here.
Yeah.
So for example, I don't actually remember what commands you used to do these ones, but like
compile it, just GCC-G, and then the output file.
But for 32-bit, because I noticed that they're 32-bit. What's the I forgot what the directive is for that.
I made these 32-bit.
Yeah, you did like yeah, no, wait, it's 64-bit. Why did I see EAX?
Thank God.
Sorry, I'm just.
You scared me there, man.
You know what? It do be one of those days. All right, so yeah, if you just GCC and say like for example loop, I'll loop.c. This one's gonna go to a.out because I didn't specify the output, as we're probably mostly familiar with. But a.out here will work the same way if I actually run it right. And then if I want to run object dump on it, it'll also give me the same kind of output. And actually, if I, well, I was going to run diff on it, but that actually probably would still differ because they compile them at different times. So little like metadata will be different. So, but like if you compare, say like the, if I want to do, oh, this already has loop in it. Cool. To do main, and I know this is kind of overkill, but just to make sure that everyone understands. So we can see that if I zoom out a little bit, these are pretty much similar, minus a couple things because they're compiled on 2 different computers. So probably different versions of compilers too. So little things could differ, but for the most part, like the structure is very similar. So we see like it references, there's a jump and link, there's a compare, there's 2 adds, you know, like it's going to be very similar to it, but yeah, you have to compile it to be able to use object dump. Object dump only will help you dump out compiled ELF binaries. I think also PE32 binaries as well. Let me double check that. Object dump, DM Intel. I think I just did this too, so yes. Yeah, I just did this a little bit ago. Oh, I need to get more sleep. Yeah, so you can basically run this on most binaries. There are other tools that will help you visualize, you know, what's going on in runtime, which you probably have used. There's one called GDB. So dynamically, if I wanted to see what's going on in this program, you know, loop, I might say GDB and then loop, and then I'll run, or if I want to break at main, I'm not going to turn this into a GDB lesson, but just trying to show you, like, I can also run disass or disassemble main. I can see everything that's in main, and then I can run it. My specific version of GDB will show me a bunch of pretty colors because I need those. And I can see the assembly and everything here, but this is very similar to what we saw in the disassembly. It's happening in runtime. So it's, yeah, there's a few different ways you can check that out. Check the assembly, and object dump is just one of the ways to do it, what's called statically, which means you're not running the program, but you're just using some tool to basically parse through whatever the bytes are, the data within the program, and see, you know, what could be going on. Later on, if you start dealing with like harder challenges and harder things, you'll start seeing where dynamic analysis kind of shines, because sometimes things do happen in a program, and that's realistic. Like a lot of times programs edit themselves, maybe not as often as in CTF sometimes, but you know, programs do weird things while they're running, and that's not always noticeable in static analysis. For these challenges, though, you should only be able to need static analysis, and it's really, we're just trying to get you to understand the structures, which is why we're going through like the basics, like branches and for loops, because the whole idea is these are building blocks, kind of like how when you program in C, they're building blocks to actually programming code. And once you start learning those building blocks, you start realizing like, oh wow, I can go to any language. You know, I can go to Rust, I can go to Go, I can go to JavaScript, and understand, you know, I may not know the syntax as well, but there's a general structure that it should follow. Like there should be a type of for loop, there should be a type of while loop, there, you know. So that's what's useful about this. And this is where, you know, sorry, I kind of started going off on a tangent with that. But yeah, to wrap it up, to answer your question, yes, it has to be compiled. Apologize. But
any questions on the challenges for people who are on it? Like I said in the announcement, just make sure you can definitely use those teaching binaries and C code that we provided you. Those are going to be very very helpful. All 4 challenges are just based on the concepts in those C programs and the binaries associated with them. So definitely cross-reference them if you're not familiar with it. If you want another thing too, I can post a link about kind of how the stack process works, because we posted a reference for x86-64, but I can also post one for stack. If anybody has any questions, feel free to post it here. Or if you want, I can make a separate channel, a separate voice channel, and I can just jump into voice channel as people need help and me and Nathan can split up and help whoever needs help.
Just one question.
Yep.
I assume this is going to be recorded, right? Do you have any idea when the video is going to go up?
It'll be up as soon as it gets processed on YouTube.
Okay.
Well, it'll be.
'Cause
I have to modify the voice a little bit because I'm still trying to nail that as well. At least the audio, but that's
Alright,
that's not
sick.
gonna take too long.
Yeah, I joined like halfway through, so I lost the first part.
You're fine.
I just joined like 2 minutes ago because I finally figured it out.
Okay.
Nice.
As a recap, in the announcements channel, there is a link posted to our GitHub repo. So I'll post it in the normal pwndevils channel again as a kind of recap for anybody who needs it. At that download link, you can find a teaching folder, and in the teaching folder, you will find a folder for each type of program. And each type of program will tell you how things are set up. If you want an order at which you should look at these files, I'd probably start with stack declarations, then strings, then branching, liblink, and then loop. These files will show you how one thing is translated, how this C code is translated into assembly. And you can see that by running object dump -d -m intel and then b/binary. Yeah, that's how you can figure out the assembly code translation of the C code. That will allow you to see the differences, and then you always want to go to main.
Yeah, all of these should have a main.
Everyone will have a main. The symbols are on, so you should be able to see them.
Yep.
These challenges are exactly similar to reversing challenges on the actual CTF instance right now. Intel.
That's
what platform are you on?
Ooh,
I'm on
yeah.
Mac. I'm on Mac too. Let me test it.
Ooh, when'd you get a Mac?
I'll tell you about that later.
Cannot believe it.
I know.
Yeah, I thought I just heard that incorrectly as well.
Oh man.
Let me check.
Yeah, because I think I saw you using it over the weekend for the CTF,
Yeah,
and I was
I
confused.
was for the CTF.
Hey Gabe, I think we need a new pwndevils president. You looking for a position?
Pascal,
guess
I have a
not.
question again.
Yeah, what's up?
Okay, so the line numbers on the left terminal, weren't they hex before, or was that a different command that you used?
They actually are hex still.
Oh, okay.
Yeah, so everything that you'll see in this output, and actually, I think there might be a flag to make it decimal, but don't do that to yourself because it's weird. Yeah, so it should be. It should be always hex. And even in like most disassemblies, all the values will usually in not like just the addresses, but like as you see on the right side of this here, you see 0x1, 0x1. So. And then as for that object dump, I know like Mac has some weird like.
I'm already exploring it. The bin utils is different, so I'll have a solution in a second.
In the meantime, does anybody have any questions? Any other interesting, thoughts about this? Feeling about this, maybe?
I'll be sure to spam the message boards after I watch it and
All right.
ask you a bunch of noob questions because I'm just starting out.
Yeah, of course.
Okay.
Just hit up one of us or throw it in the channel.
Cool.
One of us will answer.
Thanks.
Yep. Let's see. How's everyone chugging along so far? I haven't actually logged in or anything to see where people are at. Let's see, scoreboard. No
There
solves
are
yet.
no solves.
Aw, come on, guys. All right. Yeah, I probably didn't explain it then. Let's go through.
Yeah, it's all your fault, Nathan.
Yeah, it's all my fault. Let's go ahead and I'm gonna actually, Zion, you think go through just one of them at least? Yay, nay?
Yeah. Do Rev 1.
Yep, cool. All right, so Rev 1, I'm just going to pull up the seek. No, I'm just kidding. So we'll go ahead and object dump. One thing I like to do is, like, if we're doing, simple binary like this, I'll go ahead and make a basic, like, test. So temp test.c. And, just starting out, we know if this is, we can do a couple recon things here real quick. We can tell that, first off, what kind of format it is. So it's an ELF format, 64-bit, and everything's pretty much done to it. The specific interpreter, though, which will tell you what language might it be made in. This is LD Linux x86. If you look up that at all, you'll see references to C. So we can already assume, this was probably built in a C-like language, or at least C itself. So we can assume that there's probably going to be some sort of main inside this program. I'm not going to worry about the arguments for now. And then if we just object dump, tech D, tech big M, Intel, and we'll do re1 with less, of course. You could do less or more, whatever works for you. All right. So just looking at this, we have, we have our beginning of the function here. We kind of have like an ending here. So we need to worry too much about these two top parts. There's some value right here, which, we can convert. If you're wondering what this Python thing I keep bringing up is, it's called IPython. It's the command line version of basically Jupyter Notebooks, but not Jupyter Notebooks because, I don't know, I just personally prefer this over that. So you might see a little bit of resemblances like the in and all that. But if you just put a value there, you'll see it's leet. So something here is saved. So we move a value of leet to 0x4 and move that back here, and we compare it actually. So we say, all right, some value, we subtract RSP 0x10, and then we store a value, which is what this is doing. It's storing a value of leet at RBP minus 0x4, so whatever that base pointer is at on our stack. It'll go ahead and push down a little bit more, decrement, and just throw that value right there. We have 4 bytes there, it's be an integer. And then we're going to compare it, and we're going to say, all right, well, is this value less than this value, less than or equal to? And we can start kind of writing some C code here, so we can say, well, there's some int val, which equals 1337. And we can probably see, let's see, there's a print value. There's actually 2 print values here. So there's a puts and a puts. And then there's a jump less than or equal to, a jump, which this jump less than or equal to, so this is going to be some if statement, like we had looked at before, so the branching. So some if condition. And then if that condition is not met, we're going to obviously do something else. So I'm going to make this a little easier to read. I made it harder. There we go. All right. So we know there's some if condition, and if it happens, then we print f something. Because there's or puts right here, not printf, sorry. We have puts. And we do the same thing here. And if we really want to get fancy with this too, and say we don't know how puts works, we can also use in Linux what's called the man pages, which a lot of you might be already familiar with. And I'm just going to quit out of this guy. So we're going to man puts and figure out, are there any extra weird commands or, arguments that we actually have to put in there. So if it's just puts, which is this value right here, looks like we just have to put in a character or, whatever current value is there, some character pointer. So in this case, it could be some variable. It could be some value we put here. But yeah, this is what it takes. So we're good on parameter-wise. Not anything extra that we need to be suspicious about. So we know that this is one if statement, and then we're gonna say, all right, well, obviously it's gonna compare some value. So if value is less than or equal to 1337. So it's going to compare these and check. Then we're going to be printing out something. Otherwise, it's going to print out something else. So we can kind of assume that it's going to be doing that. And we can also double check, what it is printing, because, we do have the actual binary itself. Not in that folder, but in this folder, we have re1. We can see what it does. So it says you're not lead enough. So we can kind of check then, well, maybe it doesn't need to be 1337. Maybe that's the value that's like we don't want. Because obviously this condition, if we're looking at this and we say, well, jump less than or equal to, so then it's going to jump otherwise. So actually, I did this wrong. It's going to jump if it's less than or equal to, which means it should actually be if it's greater than 1337. Because if we know this idea of, I forget what the actual discrete math term is, but basically where you take some comparison value, so you have your greater than or equal to signs, you can take an inverse of those and say if you have less than or equal to, the inverse of that is greater than. And if you have greater than or equal to, the inverse of that is less than. So that's what I just did here. And this is kind of what I was saying, like a compiler might do some funky things like this. So we're saying we're going to jump away. So we're not even going to call this section right here. If this value is less than or equal to this value, which obviously it is, or at least for this value, it's going to compare it to. It very much seems so. So then we're going to jump out of that. And then we're going to execute some code over here. So I'm going to guess this section right here is actually saying you are not lead enough. So if some value is greater than that, then it's going to probably say something else. So I'm not sure if this takes any command line arguments. It might, but we can definitely check that real quick. Let's say, what about 2. Well, it doesn't seem like it does, because that's obviously greater than. So this might just be something internally within it. And I think I'm messing this up. Let's see. Yeah, so RBP, so we push that, and we take 0x1, move that into RSP. Yeah, we just take these two values, and we throw those, so we take this and throw it into here. We compare that. So it seems like it's just always going to resolve to false. And pretty sure that's actually all that comes out to. So if this came out to somehow this, we would say you are leet. But in this challenge, it may not. Let me double check something real quick and make sure I'm not completely going off the rails. Wow, okay. Yeah, so here. Let's go ahead and cat that re1 out. And there you go. So it was some value that was greater than 1337. And you were not leet enough. It was right here. So, cool. Thought there was going to be something extra. I forgot. I guess there's not. This is the first time I'm doing this one.
It is the first challenge.
It is. Sorry, I don't know. I thought there was going to be like a flag or something. And so I was like, shit, is there a flag or something? I was like totally missing because I didn't look at actually any of these re-challenges recently. So, yeah. So that's the first one. I don't know if there's... Are you putting any flags for these challenges on the thing?
So like I said, none of them, so all of them, the flag is in their description. Just don't submit the flag until you've actually beat the challenge for the first 4.
Oh, cool.
I didn't embed flags in them, so.
Okay.
Yeah. I'm going to go help somebody in the other pwndevils voice. If you're afraid to ask questions in front of all these people, just you can jump in the small one.
I just have a question.
Yeah, what's up?
So on the description of that challenge it says that you're supposed to print you are super elite. So you're saying that there's no way of doing that since it's already established, like the elite value equals elite.
Yeah, so the thing is with this, the C code for Re1, and I guess he might have just, I don't know, he might have just put the description a little wacky, but since this is all hard coded values, you would have to change basically how the program and change this specific value, because we could definitely do that. We can go into something like doing hex editing of the application, but I don't think we were planning on doing that today yet.
Yeah, that's what I meant.
Yeah. So that would be something that you would end up having to do, basically, is trying to go through like hex editors and, just modify it. Or if you wanted to go really over the top with it and take a jackhammer to a brick, basically you could take something like IDA and decompile it or disassemble it and then modify it and then recompile it. But of course, that's not what we're doing.
Okay.
A hex editor would be a lot more simpler for this, especially if you're just editing a value. And in the case of like, say if we're doing like buffer overflows, we're doing some sort of binary exploitation to this. A lot of times you'll see there would be like a buffer or something right here, some value that you can basically fill up, and it would start writing over either this first check or some value like this, which would be in front of it, and it might end up writing over it. And so that when this if statement evaluates, if it does evaluate at all, because maybe you didn't write over it, it would evaluate to true. So in this case, you would just make it like 1338, and then it would be like you're a super elite. But with a lot of this, because like he was saying, so it's a super simple challenge. It's just meant to really get you to really just go backwards. Take this code, make some structure in C with it. And some of these, I think the only one that actually has a straight up flag is the baby crack me. Like he was saying, the first four, I don't know if any of these are, unless they actually take in some sort of arguments, they may not actually print out you are super elite. I think some of them do. Like I said, it's been a little bit since I've actually gone through these, so I can't remember off the top of my head. But
Okay, thank you.
yeah, of course. Did that make sense for everyone? As far as like going through this one, like, is there any questions about maybe how I got a specific value? Any weird hand wavy stuff I accidentally did and was just like, oh, obviously this is it. If that doesn't make sense, if that intuition isn't there, just let me know. I'm more than happy to explain it.
I saw when you're typing in terminal earlier, you typed in 4 2s in a row, and it says you are not lead enough. Was that like an error or something?
No, that was just, so I was doing that. You remember how we were talking about like dynamic analysis and static analysis?
Mm-hmm.
That's just, it's very simple dynamic analysis. I'm running it to see, does the program act a specific way? So, we're familiar with command line arguments. And what I was looking at here, I didn't really notice if there was any command line arguments that it was taking. I saw that, there's this value, but I know that it looked like it was assigning something. But I wanted to verify my findings and make sure that it wasn't just some, argument I missed. So,
oh, I see, yeah.
Yeah, because in the event that it was something that it was like taking from, say, my specific, or sorry, if there was some way that it was taking from this, it would have changed. Like, say if this value was based on my command line argument, it should have said like you're super leader, some win condition, right?
Mhm.
Yeah.
Sweet.
Yeah. Is there a way to get object to display the constant strings of the program? These are seen being printed from the puts. I actually am not too sure. That can, let's see. Haven't used object dump to if you're meaning like resolving them, like as far as like instead of saying it's print puts or printf is gonna just put out this string instead of just have it there inside of the disassembly. Is that what you're meaning, Paul GG?
I was just trying to see if there's an easy way, like when it does the put s, because a lot of these like strings are constant and they won't change, so they're in the program. Like if it's just there's a way to get it to show up right next to the puts, like to the right or something.
Yeah, I wasn't too sure. I don't think there is actually off the top of my head. There might be, but I generally don't. I haven't seen that before. If there is, though, like let's find that out actually.
I'm guessing that like most disassemblers do that.
Yeah, I've seen I know like Binjo will, like Hopper will. I don't know if Object Dump will, because normally it'll show it like kind of on like the side margin. It'll say like this is the point in the memory it's referencing, or the point in the disassembly it's referencing, and it'll show you that static string. But I don't think Object Dump does.
Okay.
But don't count me on that because I could be very wrong.
Yeah, I couldn't find anything online, so.
Okay. Zion actually might know about that one, just because I genuinely am like, this string's probably there, and then I'll just run strings and kind of assume one of the strings is in that specific spot, at least for like simple applications.
Yeah.
But yeah, so does anyone else have any questions at all?
This is more a question. I don't need to be on the leaderboard, but is there a reason it's telling me incorrect whenever if you're just taking the flag from the top and pasting it into flag, right?
Yeah, it should be.
Okay, because it's not working for me at least.
Which one?
For 1 and 2.
Okay, so if you're pasting it not flag : flag, but just the flag and then brackets. I just did it on both.
Now it's working for me.
Yes.
What? Okay, I don't know why it wasn't working for me before. Sorry about that.
It's all good. No, that's fine. Let's see, how are people going? So everyone got re 2. So I'm gonna go ahead, since it seems like a lot more people are getting re 2. Go ahead and start walking through re 2, I think. And I'm going to go ahead and I'm just going to get rid of that. All right, so we're going to do re 2. We can basically do the same thing. We can say file, re 2. Increase my screen size real quick. So we see it's 64-bit, and it's got the same kind of interpreter, so we can go ahead and assume that it's C. And then we're going to use Object Dump. If I can type it outright. Cool. All right. All right. So, seems like we have just a quick look over on this. We have some jumps. We have some adds, some jumps, couple jumps here and there. We can definitely pick those out because those are really depict, are there if statements here? Are there functions? Like if you see jumps within one function and it's not like, obscure, it's just kind of, along the way. And I guess this kind of comes more with like the more you do these, you start being able to pick these out more so. But if you pay attention to where jumps are in a program, you can kind of see like which direction a program might be going if you start drawing it out, maybe. Like if you want to draw this on a piece of paper, you can definitely do that. It makes it easier. And it's actually, you'll see a lot of common disassemblers, like the one I was talking about is like Binary Ninja, or if you use like Radar, of course later on, not for these challenges, they'll have these graphs, and the way that they graph out the flow of the program is always usually based on these jumps, and just where they go inside the program, because they can branch off to one direction or they can branch off to another direction. It's really easy to represent that with the tree when you can just look and say, all right, these conditional jumps will make up the flow of this program. And so that's one thing to keep in mind if you're more visual and you want to kind of draw this out a little bit more as opposed to just looking at the code. Sometimes I know that helps me with stuff I just don't get off the top of my head. So we see right off the bat, it seems like it pulls in a couple values. So There's a value from EDI, value from RSI, and it's 14 bytes, or sorry, not 14 bytes, but 0x14, 0x20. I'm not really sure what those values are yet. So I'm guessing there's probably some sort of character value, but we can also check and see like maybe what sizes. But I don't think that those are any primitives right off the bat. They just might be a section or like of a character value or string character. But let's see. So we have another one that's doing a integer change, so it's taking in some sort of text, so some sort of value that you're maybe providing or the program's providing itself, and it should be some character value probably, and it's going to convert it to some integer. And then, let's see, we're comparing it to lead again. We are very familiar with this, just for repetition's sake. Lead, just to make sure. And we're doing another comparison. If something is lead, and then it will go ahead, maybe jump. But let's go ahead and just get out the structure first instead of trying to say maybe, maybe, maybe. So we don't know what these initial values are first. Something that's 0x14. And then something 0x20. Now, something to keep in mind too, these are like initial values, and since these are pulling from some register, it's really interesting because normally if you're assigning something, so like we saw before, if I'm assigning some character value or if I'm assigning some integer value, they're usually here or referencing somewhere else, not a register. So
my bad. The first reversing challenge is not solvable.
Yeah, we got to that.
All right. the iconic challenge that's supposed to be the easiest challenge here is not a solvable challenge.
Well, it is solvable if you put the flag in there, though.
Yes. Yeah. I guess so.
No.
If you modified it. Okay, my bad, everybody. The first challenge is not solvable. You can just submit the flag for the first challenge. My bad. It's not solvable.
You should still go through it and try to reverse it, though.
Yeah, you can reverse what it does, but this challenge, that challenge specifically I made last year, was supposed to just be like you turn the assembly into C code. But yeah, obviously that's not going to work for this format. So everybody gets a freebie, RE1, everybody can just have RE1.
Yeah, everybody's on the leaderboard.
Everybody's on the leaderboard. Congratulations, you guys all did it.
Yeah. All right. So.
My bad.
God,
my
Zion.
bad.
All right. So, coming back to this. So we know there's so it's coming from a register, which is kind of funky, right? We also got to remember too, in like C at least, there's this concept of, I can take in argument values, which is what we had checked before. But if you remember, the beginning code didn't look like this, which is where I was like kind of suspicious. Where are we getting these values from? Well, the values were right there. In this case, though, they're not. They're referencing a register. And if we look at maybe like how arguments are passed to a program, or at least how they're passed in through assembly, you might come to find that EDI and ESI are references that hold the values you pass into the program. So we can, I forget what the actual, I think it's like something argv, and then it's like car argc, or I had that backwards. And then it's like argc is int. Yeah, something like that. So those are, we'll come back to that here in a second though. Now the next part is we have those structure, because we recognize that there's probably an if statement in here. We jump less than or equal to, and this is laid out very similarly to how we had it before. We had some if statement where there's some Boolean value. So it was either true or false, would allow us to succeed this if statement. And then we'll go ahead and try to check, what could be in this Boolean value. Well, we're going to compare to elite again, and we're going to do, we're going to jump less than or equal to, and we've already seen this before, so we already know this little fancy trick that it's doing. So we can just say some value, I'm going to call it val, is greater than 1337, then this is going to succeed. So it's going to, based on this function, now this could have been printf, I put printf here, but puts is defined there, so we're not doing printf, we're doing puts. This is how I'm getting this function. So we just puts, and then something. So I'm guessing this is going to be the win condition. So win, don't know what it is for now. Could be you are super elite, probably is, who knows. But then we'll put here, puts lose. So this seems like it's like the general structure for this, because if we cross-check this real quick, we say, all right, well, if it's less than or equal to, so this would be less than or equal to, should go to the else, and so when it jumps to 6 CB, it'll jump to here, and then it loads up a value, which probably the string it's gonna print out, and then it calls puts on it. Cool. So that seems right. There's nothing else that's funky done in here. Nothing else funky done in here. If we don't jump and we just go through, we load up another value, and we do the same thing. We call a value. So these are very simple. Pretty much, there's nothing weird going on. Seems like it should be pretty straightforward. Now, for these values that are 0x14, 0x20, well, those are probably some value that's passed in. So, because we know that this is calling a toy, so it's taking a integer and turning it in, or sorry, taking a string value or some character and turning it into an integer. And we can say that there's some int, which I'm going to say val, is based on some argv value, which I don't know which one specifically. And off the top of my head, I don't know off the top of my head which value, of these is really specifically it's pulling from. It could be from the -14 0x20. But I'm going to take a gamble real quick and just check and make sure. Maybe it's 1 or 2. It could be 2 values it's grabbing, but the only comparison is to 1 value. So I'm going to say we're probably only taking in 1 value. And since we're not bringing in more than 1 value, it's probably, we'll go for now. We'll say it's argv1. Then that's where we say, all right, I think I've gotten most of this disassembly done. I actually have decompiled it into C code, which is what we're doing. We're physically decompiling it. And I'll do, what is this, re2? Yeah, re2. Oh yeah, that's right, I forgot. Let's go into this one. Cool. And we'll go into re2. Segmentation fault. This is actually an even better indicator too, because a lot of times what could cause this is one of two things, or at least one of a few things. I would say the most common ones that I've ran into, and maybe you have when you make your own programs, is that you asked for an argument to get supplied. So you're looking for an argument in the command line and it doesn't exist. So the program was like, well, that doesn't exist. I'm going to see you later. And it crashes. Another one that could be is when you're trying to open up a file and the file doesn't exist. And so it crashes, which you may see this on, say, if you're doing Pwn College, and some of the programs that come up may have certain flag files. And if that flag file doesn't exist in your system, the program hopefully will close out fine, but it could crash. And it's not a bad thing either way. It's not going to ruin your system, but that's just one of those weird debugging things you're not really sure why it might happen. Just keep that in mind. So in this case, it needs probably an argument. So I'm going to say A. I'm not elite enough. Damn, that sucks. But if you reference our decompilation, our very high-tech decompilation, we'll know that there's probably the value will need to be greater than 1337. So we'll do something greater, like 1338. And I am super elite. It's cool. So that worked. So then what's even cool too is now that I've done this, there's 2 ways I could have got probably these strings. So first off, I lost. So I know what the lose case string is. So I can basically copy this into your lose case like we did before. And then in my win condition, I know that you are super elite is going to be there. And then, you know, these are probably will have new lines or something because they didn't just trail off at the end of my console. Another way you can go about getting the strings if you wanted to, which might be a little bit more heinous, is actually running the strings binary on this. Strings on re2. There's a lot of stuff. We see all the different sections of the binary. We see every little thing that happens from the compilation phase, what interpreter it uses, yada yada. We maybe don't want that. I mean, it's pretty easy to pick these out because you'll kind of look at these and you're like, well, okay, that doesn't look like anything somebody might type in there. You know, they might, but it looks very, very structured. Like, this should be there. But then you see these ones that are like, you are not super elite, or you see, you are not super elite enough. So that's like another way to grab strings, or to grab these strings out of the binary. A lot of times, maybe if you have a flag in the program, or if there's keys in the program, you know, you can strings the program, and sometimes it'll spit out base64 encoded data, or just completely like unencoded data. It's just there, and it's, you know, maybe the flag. That's usually what can happen on really easy challenges too. But yeah, that's the second one, and that'd be the way I would go about decompiling it. Does anybody have any questions on that? Also, Zion, did you ever figure out if you could have strings at the end of or next to puts?
So not in object dump, but if you want to know what the string is a reference of, so here I'll post this in the Discord. There you go. If you use that command, this command will show you where the read-only strings are used.
Oh, perfect. Okay.
And so what you can do now is you can look at the reference on the left side. So the reference on the left side says something like, it says something like load effective address, LEA, RIP plus OXB0. So RIP is the value all the way on the far left. So, you know, I'll just share my screen. This is easier to see. So I have a little screen share if anybody's curious about how to get the strings in an easier way. The strings that you can see is over here on this left side in your main. You see all these like values: 63A, 63B, 63E, 642. These are of course incrementing values because this is the value of the instruction pointer. And in x64, that's known as RIP. So RIP is the instruction pointer register. And so what this says right here is it's going to load a value into RDI, and then it's going to print something. So RDI is the parameter for print. So it loads a value RIP plus OXAB, RIP plus OXAB. So all you have to do is you have to take RIP, and RIP is over here on the left side. So OX652, and I'll put that in IPython. OX652, because that's what RIP is, and then you have to add OXAB plus OXAB, and that gets you OX6FD. And so the location over here, all right, let me just, actually it should, by mistake, it should be adding on the next RIP, not the current RIP, but the one following directly after it, because that's the next instruction pointer. So if we do that, boom, 659, AB. All right, awesome. OX704. And if you look up here, when I did that command I showed you guys a second ago, you do readelf-x, read-only data. You'll be able to see that the read-only data of this string, you are super elite. It starts at OX700, and then 1, 2, 3, 4. Or sorry, not 1, 2, 3, 4, but 4 starting. That's right here. So that's kind of how you can figure out what it is. This is of course, this is a much longer route than you'll normally do, but still fancy, I guess. So yeah, so just use the left value right here, of this. So load effective address RIP. So just use the next value OX659, and then you add that to whatever value they're adding an offset to. So in this case, they added the offset OXAB, and that will give you the location of the string you're looking for. Yes, that is all I have.
I had a quick question.
Yeah, go ahead.
How do you know the length of the string? Because it tells you like where it starts, but how do you know like the length?
Phenomenal question. How do you know where the string actually ends? So I'm about to introduce to you the worst thing ever. It's about null terminating bytes. But you're really not going to like how this one works. So normally you look at this. So we can correspond this on the right side. So if you keep your eyes up here, you'll see that this is the first byte, which is a dot. This is the second byte, which is also a dot. Third byte, a dot. 20 is a dot. So, or sorry, 002 is a dot. So we can say right here 59. So if we look at the value in Python of OX59, my bad, do character. We know it's a Y. Of course, you could probably tell me what the next value is, 6F. Character is 6F.
Oh, yeah.
Yeah, that's a O. So the question is, what was this first 0 right here? That's the null termination of the string.
Okay, so it's after the 6574.
So it was right here. So what I'm trying to say is it's backwards. The string is backwards.
Right, but like for the next string, like on the 6574, there's a null terminating byte there again.
There it is. Yeah, you got it. The null terminator. Boom.
Okay. Yeah, that makes sense. Thank you.
So is there a reason why there's one in the beginning, and then one in the middle, and then one at the very end?
So the one at the very end is... Oh, my bad. It's not as complicated as I made it to be right there. The one in the very end is the normal null termination. This one is also the normal null termination, and this null terminator is to divide up the sections of the read-only data.
Is it because like there's specific sizes within the read-only section?
No, it's just when the compiler was storing stuff. When it's done storing something, it puts the null terminator.
Okay.
Yep. So like that's why this first 0 exists, because this value, I don't know what this value is, but it's special to the compiler.
This is my 0. No one's taking it.
Yeah, exactly. I don't know why it likes it, but that's what it likes.
It's funny.
Makes sense. Thank you.
All right, I'll stop screen sharing.
Does anyone have any questions else? We have till 6:30, so if you have questions, please harass one of us.
Yeah, this is more of a general x86 assembly question. Where do the arguments that are passed in the command line, which register are those placed into?
So that's and Zion actually might be able to speak on this more intelligently than me, but this is where I was talking about it's going to be RBP 0x14 here, and that gets pulled in from EDI, and then this 0x20 here is RSI. And I don't know off the top of my head which one comes in which, but if I had to make a guess, the shorter one is going to be the integer value, and just because you don't need much for an integer, but it's going to save up the bigger section, the bigger amount of space it's reserving for whatever arguments that are in there. So in this case, we have the one that's just counting how many arguments there are. The other one's just a pointer to say, here's all of my arguments that I'm passing in. Zion, would that be right to say?
Yeah. Could you say the question one more time?
Yeah, I was just curious. I don't have that much experience with x86. I just didn't know where to look for the pointers to the arguments.
Okay, so the pointers to the arguments.
Yeah, the command line arguments.
Okay. So the command line arguments, perfect. So whenever you're talking about the command line arguments, so there'll always be a argument to main, and arguments to a stack are always going to be before RBP. And arguments that are inside the function are going to be after RBP. So if what Nathan was talking about is you're seeing RBP minus something all over the place, RBP minus something means that it's a local stack variable. But RBP plus something means it's a parameter. So whenever you write the main function, you always have argv as a parameter, right? Assuming you've written in C before, argv you always have a parameter.
Right.
Yeah.
It's
so
the parameter pointer, right?
Yep. And so if you look at RBP plus, and you're talking about RE2, I think.
I'm looking at RE3.
Okay, I'll take a look at RE3. RE3.
So I see the D word pointer and the Q word pointer. Those being loaded into the EDI and RSI registers are now. I know D word is the first 32 bits of the register, correct?
D word is a double word, so yeah, 32 bits.
Q word. I don't recognize Q word.
Q word is quad word, so that's 64 bits.
Okay.
Yep. Okay, I'm looking at main now. Okay, RBP minus. Oh, I see. Yeah, it's the pointer is stored on the stack. Yeah, okay. See what you're saying now. And then it does the string compare on RSI and RDI. Okay.
So correct me if this interpretation is wrong. In RE3, the line in main 692.
All right, 692.
That is loading the argument count into EDI.
Yep.
And then the line below it, 695, is loading the character pointer array into RSI. And that's
yep. RSI is going into OX20. RBP minus OX20 is where RSI is moved.
I think I have the headed in there.
Yeah. Got it flipped there. Right. If you go back to that link Nathan posted, and I'll put it in the chat again, the Chromium link. In the Chromium link, you should be able to see which ones go first. So the Chromium link, they show you like all these syscalls, but the nice thing is at the top of that table, they also show you what parameters are for each register. So REX is always the first register, RDI is the second one, RSI is the third one. So you can see what the parameter order is per argument.
I have a question. So for line 692, what does EDI actually contain, or RSI?
So EDI, if we look at the syscall table right now, EDI contains the second argument. So EDI has the second. Oh no, that's actually the. Oh, yeah, that should be the second. So EDI, and let's look at what you put in main. So the first argument to main is usually the arg count, I think. Let me confirm that. What you usually put there.
Yeah, it should be the arg count and then the arg array.
And then the last one could be the environment pointer. So basically what was in EDI was the argument count pointer, a pointer to the argument count. And then RSI has a pointer to the argument pointer.
And then it's throwing that into RAX.
Yep.
And you said when it adds to it, that's referencing something that's above that stack frame?
Yep. But in this case, they're just using registers, so it can switch. So the second RSI, so you have RDI or EDI, either one's fine. You have EDI, which is the argument count, and RSI, which is the pointer to the argument array, or not the argument array, but whatever the string was that you had. So they move that into OX20, and then they move OX20 into RAX, and they reference the first thing in RAX, because if you add nothing to an array, you get the first index of it, right? Everybody get that? So then they say, so I'm looking at line 69D now. At 69D, they say, get me whatever is located at the first position of RAX. Those brackets, and they load that value into RAX. So you could like imagine this in Python as reusing your list array, like your variable that was a list array, and overwriting it with just the first value in the list array. And then after they get the first value in the argv, they load that into RVP minus OX10. And that's on line 6A0. And I can also share my screen again if... Oh, Nathan's got it. Nice, perfect.
Yep.
Nathan's got it. Yeah, on 6A0, that's where they load RAX into RVOX minus 10. So now it's on the stack. Now it's there. Then the next thing they do is, once it's in RVP minus OX10, they eventually end up putting it back into RAX. And then they put RAX into RDI. So we can see that something is comparing against our first argument in the array. Of course, if we go backwards now and we look at this again, we'll notice that they reference this array twice. And they get the second argument. So on line 6A4, you can see that once again, they're loading in the argv array into RAX. But this time, they do RAX plus OX10. Why do they do plus OX10? Because every single position in the array is also a pointer to a string. So this is an array of arrays.
You mean OX8?
So, yeah, the OX8 on 6A8, they do RAX plus OX8. Oh, did I say another number?
You said 10.
Oh, whoops. Yeah, OX8, my bad. OX8. They add OX8 because this is an array.
Now, is there a reason why it's of 8 size? Is that because it's a double, or is it like is there a specific sizing reason for that?
How many bytes is a pointer?
Pointer should be 4, right?
It should be 8 bytes in x64.
Oh shoot! Okay.
Yeah.
8 bytes.
Yeah, common. I've made that mistake too. So in x64, it's 8 bytes because how big is 8 bytes? 8 bytes is 64 bits.
That makes sense.
The address space. So they got the second argument, or at position 1 now.
Right.
Of the array. And then they loaded that. So they're comparing the first argv and the second argv and doing something. This challenge is actually really funny.
I have a question.
Yeah, go ahead.
So can you go back to how you found the address for the flag and you used the readlf command, which is not on the Mac? Like, could you explain that one more time?
All right, you're still on the MacBook.
You want to pop open your screen on this? Since you're on the Mac.
yeah, I could do that. Let me, I have a feeling I might be able to do this in a stupider way. Because when you object dump, it should also be there. Let me see if it's here. is not here, because of course, because I didn't disassemble the string section. So the way I was doing it in the Mac was also through a Docker container. Just heads up. Sorry.
Linux for life.
Linux for life, my guy. Let me see if I can get you the specific section of the read-only using object dump, because object dump I should also be able to get the read-only section. Although we are over time now.
Yeah, sorry to interrupt. Can we complete these challenges like before the next meeting, and then like see like if we did them correctly or if we need any help?
Yeah.
Or what is the next
you
meeting
wanna,
going to be about?
If you want to do them before next meeting, like feel free to. I don't. Make sure you download them now, because I don't. Zion, are you gonna keep this up, the server the entire time?
I'll keep it up. I'll keep it till the end of the week.
Okay.
I'll keep it up at least till the end of the week.
I can just download it, but yeah.
Okay. Yeah. Then well, yeah. Just finish it. If you need to take time on it, do it, and then just finish it before next meeting, so next Monday. I don't think we've completely figured out yet what we're gonna do. I think are we gonna move into like shell coding probably?
In the next meeting, we'll try to address some of the issues of this meeting, and yeah, we'll do some shell coding because it's more assembly.
All right, cool.
Okay, sounds good. Thank you, guys.
Yeah, of course.
Yep.
Bye.
Bye.
Prison Mike, let me see if I can get you that command to get you the correct place. Trust me when I say being on Mac makes life harder for everything. It's like it's Unix, but it's like Unix with restrictions.
By the way, if anyone needs to go, you're free to go. We're over time, so. But if you have questions, feel free to stay and ask or hang out. Totally fine with that too.
Yeah, thanks for the lesson. I'm gonna go eat, but I'll be back next week.
Hell yeah, yeah. See
We'll
you next
keep working
weekend.
on this.
Yeah.
Awesome.
Let us know if you have any questions. All right.
Yeah, I appreciate it. Catch you guys later.
Yeah, catch
See
you
ya.
later.
I'm trying to see if there's a way to install, because you should be able to do brew install bin utils.
I think that
But-
version of binutils is like slightly different, if I remember correctly, though.
No, it is. It is.
Yeah.
It is different, but I was hoping that it might at least be able to get you close enough to being able to use readelf. Because like right now we can't even use readelf.
Is it just that specific command is not working, or?
Yeah, readelf doesn't. It's not a